Okay, this is for any student that was absent today or that did not get their notes or just needs a little bit of extra so that they can catch up and understand what's going on for the lesson. So if you will pay attention and listen, hopefully this will help you to work through the problems or to go back through it if there was a question and you weren't sure what to do. The first thing we're going to do before we read the problem is we're going to draw a right triangle because we know that right triangles are the only thing we've been working with for the past 2 weeks. Once we draw a right triangle, we're going to come over to the problem and we're going to start reading. It says a wooden beam is important, is 24 feet long, leans, is an important word, against a wall. So right now I know I have a beam and I have a wall and it's leaning. So therefore, if it's leaning, that means that the slanted part of my right triangle is my beam, so we're going to label it as beam. It is 24 feet long according to the problem. It leans against the wall, so that means that this right here is our wall, okay? And we know we're going to have to, the wall is taller than the beam. That's the reason why I drew that part right there. And we know that it's going to be touching the ground, so we know that this part down here is the ground. All right, then it says, and, that means that they're continuing, make an angle of 71 degrees with the ground. Okay, so the 71-degree angle is between the beam and the ground. So this angle right here between the beam and the ground is 71 degrees. It says, how high up the wall does the beam reach? How high up the wall? Okay, how high up the wall? If I start at the ground and I go up the wall, I'm going vertically, that is the number that they want us to find for the X. They want us to round to the nearest foot. That means the nearest whole number. If you notice, none of our four answers have a decimal. Okay, now that I have it, I know where the beam is, and I know where the wall is, and I know where my angle is. I now come over to the triangle, and I'm going to label it using our four-step process. Step 1, find the right angle. Across from the right angle is the hypotenuse. So I'm going to label it first. Step 2, find the reference angle. Remember that the reference angle is the angle where the two meet. So, the angle that's not the right angle. Sorry about that. The angle that's not the right angle is our reference angle. Okay? That is step 2. Step 3. Across from the reference angle is the opposite side. So we label the wall as the opposite because it is across from the reference angle. Then the last step, step 4, is the adjacent side. And the adjacent side is always next to the reference angle, and it's the only one we have not labeled. So we're going to use the same 4-step problem every single time. Okay, now that we know where our 4 parts are, hypotenuse, reference angle, opposite, and adjacent, we now can decide which of the 3 trig ratios we're going to use. Are we going to use sine, which uses opposite and hypotenuse? Are we going to use cosine, that uses adjacent and hypotenuse? Or are we going to use tangent, which has opposite and adjacent? We're looking for 3 things from our problem. What is it asking us to find? And what 2 pieces of information did they give me? Which we're talking about numbers. Okay? So that's going to tell me which one of these 3 I need to pick. So if we look at the problem, we know from the problem that we're asked to find how far up the wall we go. So that's x. So what are we asked to find? This is from the wall. Okay, x. What two pieces of information are we given? We're given that the reference angle is 71 degrees, and we're given that the beam is 24 feet. Those are our two numbers. Okay, so then we look. The wall is the opposite side. The 24 is the hypotenuse. 71 is your reference angle. Okay, so my two pieces of my puzzle are these two pieces that I put a square around. The x for opposite and the 24 for the hypotenuse. OP. OH, excuse me, OH. Okay? So I have an O and an H right here with my sign. Okay? Cosine does not use an O. Tangent does not use an H. So the only one I'm left with that I can use is sine. So what I'm going to do now is fill in what I know. The sine of my reference angle, 71 degrees, is equal to the opposite, which is x, over the adjacent, which is, not adjacent, over the hypotenuse, which is 24. Okay? Now, we learned from the video, we get some trivia with it, that when the x is up high, we multiply these two numbers right here. So, I know that x is equal to the sine of 71 degrees times 24. Now, in order to complete the problem, I need to find out what the sine of 71 is, and this is where we go to our trig table. Give me just a minute to pull this up. Pause. Okay, sorry about that. Took me just a minute to find it. Okay, so from our trig table, okay, we know that we're going to go to the sine column. We're going to find 71 degrees. And then we look right at the sine column. We see that the sine of 71 is 0.946. So that's what we're going to use for our problem. Okay? Alright, sorry about that. Technical issue. Okay, so from our table, we know that sine of 71 is 0.946 times 24. Okay? So I know that x is going to be approximately, so we're going to get our calculator, and we say 0.946 times 24, and we get 22.704. Now it asks us to round to the nearest nearest foot, so that means that the 7 is going to round the 2 up to a 3. So we're going to get, our answer is 23 feet, rounded to the nearest whole number, which this is answer choice B. Okay? All right. Then, we're going to move to number 4. Number 4 was the new information we learned today, because it asks us to find an angle. So we're going to start just like we did before. Before we read the problem, we're going to draw a right triangle. Then we're going to start reading the problem. A 20-foot pole leaning against the wall, so we know that this is going to be our pole like the previous problem, and it's 20 foot. We know that this is going to be the wall over here. Okay, so that means this part down here is the ground. Reaches a point 18 feet above the ground. 18 feet above the ground. Okay, here's the ground. So if I go up above the ground till I get to the point where the pole touches on the wall, then I know that is 18 feet. What is the angle which the pole makes with the ground. Okay? So, here's the pole, here's the ground, so the angle is this angle right here, and that's what we don't know. So we call that theta. And that would be our unknown reference angle. Okay, that would be the easiest way to remember it. It's an unknown reference angle. And it's this Greek letter right here, theta. Okay, we're just using it instead of x, y, or z. Now, once we've done that, and it says they want it to the nearest degree, so again, it's going to be the nearest whole number. Okay, we just do our 4-step process. Find the right angle, go across, that's our hypotenuse, step 1. Since this is our unknown reference angle, theta is our reference angle, that's step 2, find your reference angle. Step 3, across from the reference angle is the opposite side. So that's going to be the height up the wall. That's step 3. Step 4, whatever side we have not named is called the adjacent side. That's step 4. Same 4-step process. Okay? Still have the same trig ratio. Sine, cosine, and tangent. This is what we need in order to find each one. Opposite, hypotenuse, adjacent and hypotenuse, opposite and adjacent. Okay? So, we look at it again. 1. What do we need to find? So, in this particular problem, it says they want us to find the angle, which in this case is the reference angle, which is theta. Okay? 2. What info, which is numbers, are we given? Well, from this point, we're given that the wall is 18 feet, which happens to be my opposite side. And we're given that the length of the pole is 20 feet, which happens to be my hypotenuse. So I have an O, and I have an H. I have an O, and I have an H. Sign it is again. Okay? So I'm going to plug in what I know. So I know that the sine of my reference angle, which is theta, is equal to the opposite, which is 18, over the hypotenuse, which is 20. Okay, now this is where it comes in different. We need to know what that decimal number is. So what we're going to do is in our calculator, we're going to enter 18 divided by 20. So let's go to our calculator, and we say 18 divided by 20, and we get 0.9. Now, since this is exactly 0.9, we do not have to round it. I can keep my equal sign. Now, in this video, the code says when we need to find an angle, we do the inverse, like multiplication and division, addition and subtraction. The way we write the inverse is we mark it the same trig function, but to the negative first power. So in this case, it's sine to the negative first power. All that means is we're going to find the angle. So, we're finding theta. We know it's going to be approximately because it's coming from the table. So we're going to go back to our trig table. And what we're looking for is the number that's the closest to 0.9. Now, we're only going to look down the sine column. If you will notice, the numbers are increasing. So we're going to find one that's the closest to 0.9. When I get to 64 degrees, I see that the number is 0.899, which rounds to 0.9. So my angle measure is 64 degrees. So theta is 64 degrees, approximately, which is answer choice A. Okay? Now, if you have a calculator, calculator, you can put it straight in and get this rounded answer, but you can also round it to other decimal places as well. Okay, now, the last problem I did in class today was problem number 5. So we're going to set it up the same way. Before we read the problem, we're going to draw our right triangle. We know we're only going to have the ground. Okay? Now, this time it says, when the plane had flown 4,150 feet from the airport, where it had taken off. Well, we know that when a plane is at the airport, so that means the airport is down here on the ground. You know, this is the ground. When an airplane takes off, it goes up at a slant until it gets to the altitude that it needs to fly. So this distance on this slant is how far the plane is flown, 4,150. Now, this height here is called the altitude. When it says the plane is flying at 10,000 feet, that's the altitude. It says it has covered a horizontal distance of 3,660 feet. They even tell us horizontal distance. That means that if you get in your car and you started driving until you were underneath the airplane, you would have traveled 3,660 feet, whereas the airplane has traveled 4,150 feet, because it's going at a slant as it rises up into the sky. It says, what is the angle? So we're looking for the angle. So we're asked to find the angle, which we know is going to be our theta, okay, at which the plane rose, took off, okay, from the ground to the nearest degree. Again, nearest whole number. Okay, well, if the airplane's here and takes off, it rises and goes this direction. So the ground is this direction. So our reference angle is right here. Okay? So now we're going to label 4 steps. Okay? Step number 1, find the right angle, draw across, mark it as the hypotenuse. That's step 1. Step 2, find the reference angle. Our reference angle is the angle we're asked to find. It is theta. That's our reference angle. Step 2, find the reference angle. Step 3, find the opposite side. The opposite side is opposite the reference angle. In this case, it's the altitude. That's step 3. Step 4, the side that remains that has no number is, well, not necessarily no number, but hasn't been labeled, is the adjacent side. That's step 4. Hypotenuse, reference angle, opposite, and then adjacent. We have the same function, sine, cosine, tangent. So, we go back to, what are we given? Well, we know that the hypotenuse is 4,150 feet. We also know that the adjacent side is 3,660 feet. So that's the two parts I'm going to use. A and H. OH, wrong. AH, cosine. OA, wrong. Okay, so cosine it is. So we have cosine of our reference angle, which is theta, is equal to the adjacent 3,660 over the hypotenuse 4,150. So the first thing we're going to do is our division. Okay? So the cosine of theta is equal to, or approximately, depending on how we have to round, go to our calculator, and we say 3,660 divided by 4,150, and we get 0.8819. Now, if you look at the table, all of the numbers, if you notice, are rounded to 3 decimal places. So, we're going to round our answer to 3 decimal places. So we get approximately 0.882 because on our calculator, the 9 follows the 1, making the 1 go up. Okay? So, what we're going to now do is we're going to take this number and we're going to go to our table to find the inverse. Now remember, to do the inverse is whatever the trig is to the negative first power. So in this case, cosine to the negative 1. So I'm looking for a number that's close to 0.882. So I go back to my trig table and I will look down the cosine column. And as I go down, I will notice that the numbers are decreasing. Whoops, wrong column, sorry. Decreasing. So I'm looking for the one closest to 0.883. So when I get to here, 0.883 at 28 degrees, 0.883 is within 1,000th of my answer. So therefore, 28 would be my best choice as my answer. So the correct answer is that theta is approximately 28 degrees. And that is answer choice A. Okay? Alright, so that is all 3 problems I worked in class. There is only one thing that I want to mention as far as your work on that worksheet. It asks, or it says angle of elevation, which is when you look up into the sky. So that would be this angle right here. So theta in this part would be your angle of elevation, which also is going to be your reference angle. Okay? However, you have a couple of problems that says angle of depression. Now, angle of depression is when you look down. So if you were up here and you're looking down to something on the ground, this angle right here is the angle of depression. Now, it just so happens that the angle of depression and the angle of elevation are congruent to each other. And the reason they're congruent to each other is because if you completed the drawing, you would have a square or rectangle, and those alternate interior angles are going to be equal to each other. So if they say angle of depression, you can use the angle of elevation. It's the same thing. You just need to make sure that your numbers for your heights are in the right place. And that's all I need to say. If you have any questions, please make sure you can start and stop this and listen to it over and over again as you're working through your problems. And hopefully you'll be okay, and we're going to do a fun activity tomorrow, and we're going to need these in order to solve this problem and questions being asked. Thank you, and have a good evening.